Alright, good Thursday morning to your computer tech prep. Today's lecture, the third lecture from chapter 3, covers section 3.3, and that is moving data in the network. Okay, the first thing I want to talk about on this slide is the word at the top of the page, and that is encapsulation. Basically, this whole lecture today is going to be about that, so if you have a word to write down, encapsulation might be the word of the day. So encapsulation is just describing how that communication from the server to the client or from the client to the server is packed up before it is sent out as bits on a wire. There are a lot of controls that go around the data to make sure that data gets where it needs to be. One other thing that we're going to talk about on this slide is called segmenting. We learned in chapter 2 that Ethernet and the internet is a packet switch network, meaning that data is broken up into really small pieces and it is sent across the wire in these really small pieces. Now, in Ethernet, as it is packet switched, you don't need a circuit between the sender and receiver solely for that communication to take place. If you look at the picture in the bottom, it does a pretty good job of describing segmenting. You will notice that there's a gentleman at the top sending packets out, and you'll notice that there's a lady at the bottom sending packet out. That both of these individuals are sharing the same medium, meaning the same wire, and their messages are intermingled on the wire. There are a few ones, or there's a few greens, there's a few oranges on the wire at the same time. They are sharing this media, and their packets are both traveling along that media at the same time. This is the premise of segmenting. If you look on the slide, it says different conversations can be interleaved, interwoven, what have you. The packets are traveling on the same wire at the same time in some particular order. What this does for the network, it does increase the reliability of network communications, but it also builds in an increased level of complexity, as you will start to see today in this presentation. Okay, so data encapsulation. So we have some words over on the left-hand side of the screen. We have data, segment, packet, frame, and bits. And this is sort of our encapsulation chart. This is how the encapsulation of data goes. So the gentleman is sitting at his computer and he's presses send on an email. So the first thing the computer does, it segments that email. It takes the data and it breaks it up into smaller pieces. After it breaks it up into smaller pieces, it puts port numbers around the data. So prior to the data, you're going to get a source and a destination port number attached to the data. This is called a segment. A PDU up at the top, that's a fairly generic term to describe data, so a PDU. So a PDU with only the transport layer on it is known as a segment. When data has a transport header on it, it is called a segment. As it is further encapsulated along the way, again, had the email data, it was broken into pieces, segments smaller, the transport layer, the port numbers are added to it. As it moves on down the chain, the next thing that gets added to it is the network header. And the network header consists of source and destination IP addresses. When the network header is added onto this PDU, it is now called a packet. It moves on down again prior to sending, and a frame header is wrapped around that packet. So on the left-hand side, the frame header includes the source and destination MAC addresses and a couple of controls, and on the right portion of the frame header, that contains the frame check sequence, which is there to error check the frame. So it is wrapped around the network and the transport and the data, and that is what we call a frame. Once it is a frame, it is turned into bits on a wire, or little pulses of electricity that are sent from your computer. So again, you have the data is broken up into segments with port numbers added to them. These segments become packets when IPs are added to them. These packets become frames when MAC addresses are added to them, and they are set on along the way. This is the process of encapsulation. Basically it's the exact same thing that we just talked about. The web server is getting ready to send a web page to the web client. It has data. The data is broken down. the data is added. A TCP header is added on that, making it a segment. An IP address is added to that segment, making it a packet, and an Ethernet frame is wrapped around that IP packet. So we're just going to call it a frame. The data is turned into ones and zeros, and it is sent to the web client. That is encapsulation. Now on the other end, once that web client gets these ones and zeros, they reassemble this frame and they start to take it apart piece by piece. They look at the Ethernet portion, they look at the frame parts. Is this my MAC address? Is this destined for me? Yes. Then I'm going to strip that frame header off. Is this my IP address? Absolutely. I'm going to strip that IP address off. Port numbers. The port numbers are going to tell this particular PC what program to open the data up with. So the program strips the TCP, you opens the data with whatever program that tells you, and you have your useful data on your computer. That is de-encapsulation. So somebody packs it up, somebody unpacks it. Encapsulation, de-encapsulation. Okay, so when we're going to talk about the resources at all of these layers of the OSI model through this process, the physical layer is going to be in charge of timing and the synchronization of bits. And I'm pretty sure you're familiar with the word synchronization. It puts them in sync with the network. So the data link layer are going to be, like we said, your MAC addresses, your source and your destination MAC addresses. MAC addresses, don't forget, can also be called your physical addresses. If they're burned in, they don't change. They are MAC addresses. They are specific to the device. Next up at the network layer are your logical addresses, the addresses that you put on them yourselves. Logical addresses are the IP addresses. The transport layer is going to talk about adding the port numbers and also what type of transmission it is, whether it is TCP or UDP, and the upper layers are going to encode the application data and make sure that the data works with whatever application it's going to be using. Okay, so here we go. We're going to take this little example. In this picture below, PC1 is communicating with the FTP server. You will notice that PC1 has 192.168.1.110 as the IP address, all A's is the MAC address. The FTP server has 192.168.1.9 as the IP address, and all C's as the MAC address. And so PC1 is trying to get some data to the FTP server in this scenario. You will see at the top you have the data link, you have the frame part, you have the source and destination MAC addresses, you have the network, the IP packet header with the source and destination IP addresses, and the data. Now, one interesting thing to think about here is the only thing between the PC and the FTP server is that switch. You know that switches forward information only on MAC addresses. So realistically, all that you need to know to get from PC1 to the FTP server is a MAC address. You don't really need to know the IP address. That's something to think about when we're talking about communication in our LAN. Communication in our LAN is based on MAC addresses. One thing you might think about, well, I know typically if I'm going to see if another computer is connected to me, even in my LAN, I'm going to use the same thing. I'm not going to say ping MAC address of this distant computer. I'm going to say ping IP address of this distant computer. So how does my PC figure out what the MAC address is of that distant computer that is in my LAN? And that's where we come up with something called an ARP request. ARP is known as Address Resolution Protocol. Before your PC can get to the FTP server, it's got to know the MAC address of that FTP server. Chances are it knows the IP address, but it doesn't know the MAC address. So your computer has to send out an ARP request. An ARP request is a broadcast message. It's a shout out to everybody. Hey, I'm looking for 192.168.1.9's MAC address. Who is this? So the FTP server says, hey, somebody's trying to get in contact with me. They need my MAC address. They respond to the ARP request, and then PC1 has an ARP table on its computer that links up that 192.168.19 to the MAC address of all C's. And that is how traffic moves on the local network. Your PC uses an ARP request to figure out what the IP address is of something, or what the MAC address is of something that you know the IP address for. That is ARP. Now let's say you were trying to get off of your network. So instead of sending out an ARP request for the distant PC, you don't care what the MAC address of the distant PC is. You only need to know the MAC address of what's going to get you out of your network. So in this scenario, this person is PC1 is trying to send to a web server way over on a distant network through the cloud, 172.16.1.99. But to get to him, he has to go through his default gateway. So his PC understands that I'm trying to get off the network, and I have to get to my default gateway. So what the PC1 is going to do when it's going to send this message, the first thing it's going to do is send an ARP request, but not to the distant PC. It's going to send an ARP request simply to its default gateway because it has that IP address and say, hey, what's your MAC address? I got to get something through you. Sends the ARP request, the router returns its MAC address for the default gateway, and PC1 sends it off and on. Now once it hits that router, the router is going to send stuff based on IP addresses. But again, inside a LAN, you're really dealing with MAC addresses to move you hop to hop. Pretty much the same thing is going on in this situation. For anybody, either the web server or the PC, to get to the other person, their message, let's say PC1 is going to send a message to 172.16.1.99. You will notice that the source MAC address is all A's, A. The source IP address is 192.168.1.110, which is definitely that PC. Let's take a look at the destination addresses, though. The destination IP address is definitely the IP address of the distant server, 172.16.1.99, but if you focus in on the destination MAC address, you will notice that the destination MAC address is not the MAC address of the server. You're never going to know that. The only thing that you're going to know is the MAC address of your default gateway, and that is what is depicted in this picture. So don't think that the destination MAC and destination IP address will be specifically the same device, because they will not be. Realistically, internet transmissions are moving hop to hop based on MAC address, with routers pushing you in the direction of the network you need to go, and switches on the LANs pushing you through based on those MAC addresses. Hey man, alright, we are done with this chapter. Chapter 3 is done. So let's take a quick look through our summary, man. Data networks are systems of end devices, intermediary devices, and media connecting the devices. Yes, communication must have some rules to happen. The TCP IP protocol suite is what is used for Ethernet. Protocols are created by standard organizations. We use the OSI and the TCP IP as network models. Encapsulation is the passing down through the stack of the OSI model. De-encapsulation is a reverse process. OSI model talks about encoding, formatting, segmenting, encapsulating data for transmission over the network. TCP/IP has developed over many years. PDUs are named according to the protocols in the TCP/IP suite. Data, segment, packet, frame, and bits. You gotta know that. The segment has the port numbers. The packet has the IP. The frame has the MAC addresses. You gotta know that. The segment has the port numbers. The packet has the IP. The frames have the MAC address. I could repeat that a couple more times. Alright, that is the end of our chapter, chapter 3. So, work that you need to get done for Thursday. You have chapter 3 reading guide part 3. This will be done solo. Again, this will be done solo. Has to be turned in today for credit. Each of the assignments from today have to be turned in today to get credit. Your second assignment is called Packet Tracer Explorer Network. You should be fine to do that one on your own. If you want to talk to somebody about that, that is fine. But again, you each need to do your own work with your own PDFs and turn them in. And lastly, lab using Wireshark to view network traffic. You can do this specific lab on your one-to-one device. You have Wireshark, and you can view the network traffic for this lab right on that computer. So 3 10-point assignments, and that will finish off Chapter 3 for us. Tomorrow when I get back, we're going to do another Wireshark lab. We'll set the lab up to do another Wireshark lab, and we will prepare for an upcoming test on this information. So I will see you guys tomorrow. Have a good Thursday.